So factoring a difference of squares. So example 3, we're asked to find the following products. So we're being asked to multiply. So we've got the quantity x minus 4 times the quantity x plus 4. And so we're going to look at this with the partial products method that we've been using. So x minus 4, x plus 4. So x times x, we get x squared minus 4x plus 4x minus 16. And when we combine our like terms, we're going to get x squared. But now we have a plus 4x, and then we're going to take away 4x. So we have 0 x's left. So 0 times x is just 0, and then subtract 16. Okay, so when we multiply x minus 4 times x plus 4, that's equivalent to the quadratic expression x squared minus 16. Now remember, in a quadratic expression, it's necessary that we have an x squared term, but x terms and constant terms are optional, so it's okay that there is no x term here. So x minus 5 times x plus 5, x squared, negative 5x plus 5x, 25. And again, if we collect like terms, we get an x squared, and again, we have positive 5x and a negative 5x, so we're going to get 0 x's, so 0 times x is 0, and minus 25. Okay, so x minus 5 times the quantity x plus 5 is equivalent to x squared minus 25. And the last one, you can kind of detect a pattern here. We're going to get 9x squared minus 21x plus 21x, and negative 7 times positive 7, negative 49. So again, when we collect like terms, we're going to get 9x squared minus 49. So the quantity 3x minus 7 times the quantity 3x plus 7 is equivalent to the expression 9x squared minus 49. Okay, so each one of these we were asked to multiply, so our actual answer is the expression where we've multiplied and combined all of our like terms. So what happens when you simplified your answer in all of the above problems? And in this case, we didn't get any x terms. Okay, or we got an x term with a coefficient of 0. Okay. So this leads us to something that we're going to look at called the difference of squares. So if we go back for a section and think about what square numbers are. Okay, so x is a square number. Okay. If you can make a square given x number of blocks. So for example, if you were given one square block, number of, let's actually put in here, they're pictured that way, but to emphasize, we're given square blocks to begin with. So if you're given one square block, you've got a square. Okay. If you were given 2 square blocks to put side by side, it would either look like this or like this. Neither is a square. And if you were given 3 square blocks, put them like this or like this. Okay. But we don't get a square. Okay. Or we could put them like this, but again, not quite a full square. Okay. So our next square number is 4. Okay. So here we've got given 4 square blocks, we can make a square. 3 rows of 3, we get 9. 4 rows of 4, 16. 5 rows of 5 is 25. 6 rows of 6 is 36. And 7 rows of 7 is 49. And those keep going. So in each of the simplified expressions in example 3, we got an expression that was a difference of squares. Okay, difference meaning subtract. So in all of these we had a difference. They were all subtract problems. And here we had an x squared, it's a squared term, coefficient of 1. 1 is a perfect square. 16 is a square. Here x squared is a square. Its coefficient 1 is a square. 25 is a square. Okay, here 9 is a square, x squared is a square, and 49 is a square. Okay, so in each one of these we have a difference of squares. Okay, so if we think about working those problems backwards, okay, we want to factor the following. So we should recognize that 16 and x squared are both squares. Okay, so this is a square, and this is a square number, and we have a difference. Okay, so we have a difference of squares. Okay, so to get 16, let's look at its square root, 4 times 4 to give us 16. And 1 times 1. And to get a negative 1, we need one of these to be positive and one of these to be negative. So if we multiply these out, we're going to get 16x squared plus 4x minus 4x minus 1. Again, when we collect like terms, we're going to get 16x squared minus 1. So this factors as 4x plus 1 times 4x minus 1. Okay. 9x squared, take away 4. Again, we should recognize that we have a difference. And again, we have a square and another square. So 9x squared and minus 4 are first and last terms. And we're going to think of them as squares. So to get a 9, 3 times 3, and to get a 4 and negative, a negative 2 times a positive 2. So it's going to give us negative 6x, positive 6x. So again, when we collect like terms here, we're going to get 0x, just like we did here. And we're going to get 9x squared minus 4. So this factors as 3x minus 2 times 3x plus 2. Okay. And our last one, 25x squared minus 49, again, we should recognize these as square numbers. This is also a square, and we're subtracting. So again, we have the difference of two squares. So to get 25x squared, we're going to think about doing that by 5x times 5x. And to get a negative 49, a negative 7 times a positive 7. So this is going to give us a negative 35x and a positive 35x. So again, our x terms here, when we combine, we're going to get 0x, which is 0. So 25x squared minus 49 factors as 5x plus 7 times 5x minus 7. Alright, so now in the online homework system, if you want to check if something's been factored correctly, you can just click your button to check answer. Okay, but we don't have that feature when we go to take an exam. So there's a way using the table feature to check that you really do have equivalent expressions. So if we recall the definition from the last unit, equivalent expressions are expressions such that when each variable is evaluated for any real number, okay, for which the expression is defined, okay, the expressions give equal results. Now, the table feature is not going to try every real number, but it's certainly not going to evaluate the expression at every real number. But it does enough for us to see if the expressions are equivalent or not. If we can see that at a few numbers they evaluate the same, we've probably factored things correctly. And more importantly, if they do not evaluate the same at a couple points, then we know we've messed up somewhere. All right, so to use the table feature on the calculator, we're going to start by pushing y equals to get into that graphing view screen. And next to y1, we're going to type the left side of the equation. So 15x squared plus 11x minus 14. And again, to get an x, you're going to use that button that looks like this. Okay. And then next to y2, we're going to put the right side of the equation. So parentheses 5x plus 7, and another parentheses 3x minus 2. Okay. And we want to know if these are truly equivalent expressions. Okay, so once we've typed these in, we can hit Second and Graph to view our table. And we set up the table earlier this semester so that these are at integer values. So you may have to scroll up or down to find back to the point where it starts at 0. And on your screen, next to 0, you should see negative 14, negative 14. Okay, that means if we plug in 0 to the left side of the equation, we can see that we would get negative 14 because all our x terms here would be zeroed out. And if we plug in a 0 on this side of the equation, we'd get 7 times negative 2, which is negative 14. So both of these expressions evaluate the same at 0. Okay, that's not enough to show that they're equivalent if they evaluate the same at only 1 point. Okay, but we can see at 1, we get 12 and 12. And so if we plug 1 in for x on this side of the equation, we'll get 12. And if we substitute 1 for x on this side of the equation, we get 12. Okay, so now we've got 2 points where these evaluate the same. And at 2, we see we get 68 and 68. So again, we certainly haven't checked every real number, but we've checked enough that we can be fairly confident that we have factored this correctly. And so these, we're looking for these to be the same. And so we do have evidence that 15x squared plus 11x minus 14 is equal to 5x plus 7 times 3x minus 2. Okay. And again, if we want to know if we factored this one correctly, again, we would go back and push y equals, and we're going to put this expression in for y1 and this expression in for y2, just like we did here. One left side was y1, and right side we put in next to y2. And again, we can hit second graph to look at our table, and we get 35 and 35. So they evaluate the same when x is 0. At 1, we get negative 3 and negative 3, 7 and 7. So again, we can see that these are the same. Okay. So again, we have not checked every real number, not by a long shot, but we certainly have evidence that 24x squared minus 62x plus 35 is really equal to the expression that we were given. Okay, so in factoring, if we're told to factor, like I said, in the homework we could just press, check answer. But if this were a problem on an exam, again, we could put in this expression next to y1, this expression next to y2, pop open the table and see if they evaluate the same. And if they do, we can be confident that we have factored correctly.